welcome. Let's read this question together, and then you might pause the video and try it on your own. They want to know which sequence of transformations takes triangle A to its image, triangle B. So how do we get from A to B over here? What do we do? Let's look at the options they give us, and that might be where you pause the video and try it on your own. So why don't you read through the options and try it on your own. Okay, so first, they say is it a reflection over the x-axis translation 2 units down. So a reflection over the x-axis, let's identify what that would look like. The x-axis is right here. A reflection over that axis would give you a triangle down here in this third quadrant. And you can find the x-axis by find the reflection, by taking each vertex, each point on the corner here, and finding how far they are from the x-axis, and then reflecting them exactly in the opposite direction. So I go down 4 units from this point, and then another 4 units in this direction will give me that point reflected. Over here I go down 9 units, and then another 9 here, and then I go down 4 and 4 again. So here we have, if I just draw this triangle, we might be able to see what it looks like. Might be able to understand, why this is a reflection of the x-axis. You can see it's almost like the x-axis is a mirror and we're reflecting A across it. Then a translation is simply a sliding up or down or up and down of a shape. Then they say take that shape and slide it 2 units down. So I'm going to take that again and then just take each vertex and bring them down 2 more points here, here, and then it's off the grid but right there. So that would be this orange triangle ultimately, first reflected and then slid or translated down 2 units. But that's clearly not what we have here. If I go to my next option, they say it's a reflection over the y-axis and then a translation 2 units down. So first of all, again, take your vertex, your point right here, and now I'm going to go 3 units toward the axis, the y-axis. Right, let me highlight the y-axis. That's this right here. So it's 3 units towards the axis, and then another 3 units past it, here. That's the reflection of that point. Then we go over 8 units towards the axis here, and another 8 here. And then we go over 9 and 9 again, right here. So if it was a reflection on the y-axis and that only, you would get this triangle, this purple triangle. But then they say translation 2 units down, and if we look, that does give us a match, right? We take this vertex and we shift it down 2 places to get this one. This vertex shifts down twice here, and this twice to here, which gives us this new triangle, this image, the image of A. So these kind of situations, what you might do is just test out the sequence to really understand what's happening. And so the answer is B. But just for fun, let's look at C so we can make sense of what that might look like, right? So let me just clear some of this off. Okay, so we know the answer is B, but let's just look at what C would look like. A translation 2 units down. So first of all, I'll take every point and bring it 2 units down. That gives me this triangle right here, right? I'll connect those dots. Okay, that's our translation. Then a rotation about the origin, 90-degree rotation about the origin. So rotation is about the origin. They don't tell if it's clockwise or counterclockwise. Typically, a rotation is actually counterclockwise. So to figure out the 90-degree rotation, what I would do, it's around the origin. That's kind of like having the center of our, well, it is having the center of our rotation at the origin. It's like having a pin, and we're going to spin this paper around that pin 90 degrees in a counterclockwise direction. What's going to happen? Well, I'm just going to show this point. We'll start there as an example. Well, that point, if I draw a line to the origin, it's like a rope being drawn. That's what I picture in my head. Like we're swinging this rope exactly taut, like pulled all the way. We have the rope from the origin to this point. We're going to swing it now 90 degrees counterclockwise. Where's that going to end up? Well, the rope's not going to gain length. We want to keep the length the same as we turn at 90 degrees, and it's got to be the same distance from the origin. So to get to this point, I have to go over 3 and up 2. So the same has to be true for our new point, right? And if you start to swing that rope down, you can kind of imagine that it would end up right here. And, oops, oh boy, sorry about that. If I swing that rope around, it would end up, you can see about 90 degrees happening here. And I look for that 90-degree angle, right? I see it here. It's the angle between the line that we drew to the origin at the beginning and the new line to our new point here. It's 90 degrees. And I also noticed that our original point was -3 and then up 2. And now our point is -2, -3. Right? So we can see that 3 and 2, the absolute values are being used again, but they're swapped. So it tells me it's the same distance. And the same thing happens here. I could draw a line all the way to the origin again, right? And this point, if we look at it, what it is the point -8, 7. Okay. And now I've got to find a point down here that's a rotation of 90 degrees. So I look at this and I just kind of estimate, okay, it's somewhere over here, right? And I know it's got to be the same distance, so I know I'm going to be going this time right to this point. And the way I know that, this point is -7, -8. I have the same numbers, right, 7 and 8, but now the same absolute values, but the y and x have switched positions. I also can tell, it's hard because my diagram is already getting kind of sloppy, but I can tell that we have a 90-degree angle here. It's a right angle between these two lines. And those two things together convince me that I'm in the right position. And then finally, this point, -9, 2, right? We draw a line to that point. Okay, and now I got to find the where the new point would be if we rotated that 90 degrees around the origin. So I'm going to kind of start by estimating, and I have to keep going to get that about 90 degrees. That's about, you can tell it's kind of going to be around here. But I'm going to go down a little bit here because I know I have to reach the point -2, -9. I know I need to have the same distance, right? I couldn't pick any other point around it because to get all the way to that original point, I have to go back 9 and up 2. So now I go back 2 and down 9. It's the same distance. So what's going on here? It's really sloppy. Sorry about that. If I connect these 3 points, I'm going to use red. I'll use green to do that. I just want to show you what this triangle looks like. Right, same triangle. It's been translated and rotated. Although, I'm sorry about my color coding right here. It definitely throws us off. But the point is when you're rotating one of these polygons, you just take one vertex at a time, draw a line to the origin, and start by estimating, okay, where do I have to rotate that line to, right, to get the 90-degree angle. Then when you think you're about to the right spot, what I do is I look at the absolute value of the x and y and make sure they're switched, but the same, right, same absolute values, different order, same absolute values. All right, hope I didn't confuse you too much. Sorry if my diagrams are really got cluttered right there. I'll definitely make some more videos that are less cluttered. Thank you.